Okay, and we're back. I promise I'll try to make this one faster than the last two parts. And I need to point out something. I did do a little bit of rearranging down here. I moved these around a little bit so we'd have a little more room down in the lower right, but everything else should be the same. So we are here finishing up example 10.8 from our chapter 10 notes, and we're going to be finishing up part C. So we did A up here, B over on the left, and then C as well. We took this question, which was how far will the block slide before coming to rest after being shot by a bullet. We took it and broke it up into three parts. We found the final velocity, that is, of the block after the bullet passed through it. Then we went on to say, okay, well, what would be slowing this block down? Well, that would be the friction force right here, and we found that. Both of these we have boxed off in dotted lines. And now the final part is the actual question of how far will the block slide before stopping. Okay, how far? Well, that involves displacement. Okay, and displacement, well, we haven't been talking about displacement very much, so this sounds like a kinematics problem. In fact, we have a couple different velocities, or a couple different velocities of this block. We have an initial velocity of the block. Now, we had been calling it V final, that is V final after the collision, but in terms of slowing down, it's really the initial velocity of the block slowing down. It's at that velocity before it starts to get slower and slower and slower, then comes to a stop. So that would be our initial velocity for part C, 10.8 meters per second. Okay? And if you think about it, what would the final velocity be? Well, we're talking about the block coming to a stop, so the final velocity would have to be, well, rest. V final would have to be at 0 meters per second. You understand how this right here, we call it our final velocity, but we meant that's final, that is, after the collision. But since we're talking about the block slowing down to a stop, it's the initial. And then 0, or at rest, is going to be our final velocity. Okay, so we know those two. We don't know, and I'm going to write this in red, delta x. How far will it slide? Okay, we don't know that. We don't know really anything about time, how long it takes to slow down. But one thing we could do is we could solve for the acceleration. The acceleration, or really it would be deceleration, right? Because this block is slowing down. What would be slowing this block down? Well, it would be friction. We talked about that in the last video. So this right here, this acceleration is going to be very important. Why? Well, because acceleration, displacement, final velocity, initial velocity, all these are involved in one of our famous 5 kinematics equations that we discussed at the beginning of the year. So let's make our job right now finding out what the acceleration is, and then we should very easily be able to solve for our displacement. So we said in part B that the net force acting on this block coming to a stop is friction, kinetic friction, which ultimately was 4.41 newtons. Okay? But it's also true that the net force on any object, and this should look familiar to you. Remember, we used to always draw these. That's like saying, hey, these are the same. Net force is also what? It happens to be friction, but Newton's second law tells us it also happens to be mass of the object. In this case, it would be the mass of the wood block times the acceleration. Newton's second law says net force on an object is its mass times its acceleration, which also happens to be the only force acting on it, which is the friction force. So let's set the friction force equal to mass times acceleration, and we should be able to solve for acceleration. If kinetic friction equals mass times acceleration, then that means that the acceleration is going to be kinetic friction divided by the mass. mass of the wood block. So that would be 4.41 newtons divided by what's the mass of our block. That's up here. It's 2.25 kilograms, right? 2.25 kilograms. Okay, so we set the two net forces. I shouldn't say two net forces because it's net force is a net force, but net force can be stated two different ways. It can be stated as, well, the only force acting on the block, which is friction, and mass times acceleration. So that's why we set them equal to each other. Okay, so drum roll, what is our acceleration, or really, what is our deceleration? That looks like it would be 1.96 meters per second. Now I failed to do something. Since friction always acts in the negative direction, that would make our friction be negative, and I should make it negative over here. And that would make this negative. So it would really make our acceleration negative. Put a box around it. But you probably already knew that if it's slowing down, well, it must be decelerating. So our acceleration is negative 1.96 meters per second. Great, let's write that in here. Negative 1.96 meters per second. Hey, look, now we have pretty much all the components to solve for displacement, or to solve for x, or the distance this block is going to slide. That is required in one of our kinematics problems. One of our kinematics equations. And if you look at our kinematics equations, you'll see one that should look very familiar. V final squared equals V initial squared plus 2 times the acceleration times delta x. In fact, I'm going to write those last two in red because delta x. That's our money right there. We want to solve for that. So let's just rearrange and solve for delta x. Delta x, it would appear, would be equal to, I'll write the rest of this in black. Let's see, let's subtract the vi squared, and then, so that would be v final squared minus vi squared. And then to get rid of this 2a, it's multiplied by the x, so we're going to have to divide. Divided by 2a. And let's just plug and chug now. V final squared, that's easy, that's 0. Minus, what's our initial velocity? Well, that's the velocity of the block as it's sliding after the bullet hits it. And that's what we talked about before. That's this right here, that 10.8 meters per second. So let's plug that in. 10.8 meters per second. That value squared, okay, divided by 2 times our acceleration, negative 1.96 meters per second. Okay, so we're going to find really that we're going to find this is going to be, actually it's not going to be negative, it's going to be a positive delta x, but doesn't really matter. Let's simply solve for our delta x. So 10.8 squared divided by 2 times negative 1.96. And that comes out to be, and here's our final answer. Let's write this in red. 29.8 meters. This is our final answer. How far will the block slide before stopping? 29.8 meters. And there you have it. So we used friction, our knowledge about friction and how friction acts as a force, and how the force on an object is mass times acceleration. And we combined that with our initial velocity of the block sliding that we found with our knowledge about conservation of momentum. So all these parts of physics work together. So I hope that wasn't too confusing for you. I hope that breaking it into 3 parts, part A, B, and C, helped kind of chunk it a little bit, but this should be our final answer. 29.8 delta x equals 29.8 meters. there you have it. Hope that helps. Come to class with questions if you have any, and I'll see you then. Take care.